All right, class, welcome back. We're here for number 4. I'm back to pointing at the paper version of this now because I want to actually point at the points I'm talking about. In this question, we're asked to use the first derivative test to decide on what intervals this function, sine squared plus sine x, is increasing and on what intervals it's decreasing. Actually, the question only asks on what intervals it's increasing, but we'll get it anyway. So the first thing we need to do here is to take the derivative. Now there's a couple ways we've taken the derivative of sine squared. One of them is to use the chain rule and view this as the composition of x squared and sine of x. The other is to rewrite this as sine of x times sine of x. I'll do that one here because I took the derivative of sine to the fourth earlier in this video using the chain rule method, so I'm just trying to show different things so that you don't get too bored watching these videos. Alright, so once I've written it like this, then when I go to take the derivative, this first part here, cosine of x times sine of x, plus sine of x times cosine of x, plus cosine of x. And so I want to clean all of that up as much as I possibly can. So that is 2 sine of x cosine of x plus cosine of x. And I want to know when this is 0. So the way I'm going to solve that is to use this trick that we've seen a lot throughout this whole course sequence, which is I'm going to factor this thing that I have left over. And the thing I notice factors out of this is cosine of x. So here this is cosine of x times, and then times 2 sine of x plus 1. And so I have 0 equals the product of these two things, and so that means my solutions to the original problem actually come from places where cosine of x is 0 or where 2 sine of x plus 1 is 0. Remember, all we're doing here is we're setting the derivative equal to 0, so we're looking for all the spots where the tangent line is horizontal. And I can see from the picture that there is 1, 2, 3, 4 of those inside the interval that I'm looking for. So I'm expecting to find 4 solutions here. Okay, so here I'm solving cosine of x is equal to 0. As it happens, cosine of x is 0 at 2 places on the unit circle, namely pi over 2 and 3 pi over 2. And here, 2 sine of x plus 1 equals 0. That would tell me sine of x is minus 1/2. Okay? And conveniently, we actually already solved exactly this equation earlier, so you can look back to the previous video and look up that this is at 7 pi over 6 and 11 pi over 6. Okay, and so these are our 4 points that we can see in the graph here. It's that point, that point, that point, and that point. Okay, so here is where we have to make our number line. And so I have to put these numbers in order. So at the one end of the number line, I've got 0. At the other end, I've got 2 pi. And here it might help to have the unit circle to put these numbers in order and make sure you get them in the correct order. So pi over 2 is here. Then 7 pi over 6. Then 3 pi over 2. Then 11 pi over 6. Okay. And so on each of these 1, 2, 3, 4, 5 intervals, the function's either increasing or decreasing. And again, these 1, 2, 3, 4, 5 intervals correspond to the 5 pieces of the graph between the endpoints and the spots where the derivative is 0. So namely, they correspond to this piece of the graph, this piece, this piece, this piece, and that piece. Okay, so these two pieces match, and on that interval, our function's increasing. These two pieces match, and on that interval, our function is decreasing. Likewise, here it's increasing. Here it's decreasing. And over here, it's increasing. Okay, and our way of writing this answer is to say, okay, well, what intervals is it increasing? Well, it's increasing on, and then we'll write this interval 0 to pi over 2, 7 pi over 6, to 3 pi over 2, and 11 pi over 6 to 2 pi. Okay, and so that gives us our answer to this question. For this and all the questions, remember that if you have any questions for me, leave them below in the comments, and I'll reply to them either in text or video. Until next time.